What if the universe is hiding its true story in plain sight, where invisible matter shapes everything we see, and the echo of creation still whispers to us? This is your guide to the cosmos. Let's begin. Welcome. In our daily lives, the universe can feel distant and abstract, yet its story is our story. The atoms that constitute our bodies were forged in the hearts of long-dead stars. The physical laws that govern a falling apple also command the motion of galaxies. This summary will guide you through the fundamental concepts of astrophysics, offering a clearer picture of our cosmic home. We will journey from the very beginning of space and time, explore the invisible forces that shape the cosmos, and consider our place within this vast expanse. The goal is not to overwhelm with complexity, but to provide a foundational understanding of how the universe works, all within a concise narrative. Chapter 1. The First Moments. To understand the universe, we must start at the beginning. Current evidence suggests that everything we know, all space, all matter, all energy, was once contained in an extraordinarily hot, dense state. This was not an explosion into space, but a rapid expansion of space itself, from a single point. In the earliest fractions of a second, the universe was a seething soup of pure energy. This energy constantly coalesced into pairs of particles and their antimatter counterparts, which would almost instantly collide and vanish, converting back to energy. As the expansion continued, the cosmos cooled. When the temperature dropped sufficiently, more stable particles, like quarks, could form, which then combined to create protons and neutrons, the building blocks of atomic nuclei. For about 380,000 years, the universe remained too hot for these nuclei to capture electrons. It was an opaque fog of charged particles and light. As cooling continued, a pivotal event occurred. Protons and neutrons finally captured electrons, forming the first neutral atoms. With this, the cosmic fog cleared. Light, which had been trapped, was suddenly set free to travel across the universe. This released light, now greatly stretched by the expansion of the universe, still fills the cosmos today as a faint microwave glow. Chapter 2. Universal Laws. A cornerstone of modern science is the principle of universality. The same physical laws that operate on Earth govern the entire cosmos. This was a revolutionary realization. Isaac Newton demonstrated that the force pulling an apple to the ground is the same force that holds the moon in orbit around Earth. This consistency is what allows us to understand distant stars and galaxies. The light from a star a billion light-years away is produced by the same atomic processes we can study in laboratories on Earth. These laws are characterized by fundamental constants, like the strength of gravity or the speed of light. These values are not arbitrary. They appear to be the same everywhere and at all times. The speed of light, in particular, is a universal speed limit. Nothing with mass can reach or exceed it. Furthermore, the influence of gravity also travels at this speed. This consistency means that any potential intelligent life elsewhere would be discovering and working with the same unchanging rules of physics that we are. Chapter 3. The Echo of Creation. The released light from the early universe, predicted in the mid-20th century, was accidentally discovered in 1964. Known as the Cosmic Microwave Background, or CMB, it is the oldest light we can observe. It is not the light from any star or galaxy, but a nearly uniform glow that permeates all of space. The CMB is often called the afterglow of the Big Bang. Its discovery provided the first strong, direct evidence that the universe did indeed have a hot, dense beginning. By studying tiny, faint variations in the temperature of this background radiation, scientists can map the infant universe. These tiny fluctuations in density were the seeds from which all future cosmic structure grew, the eventual sites where galaxies and clusters of galaxies would form. The CMB is therefore a cosmic fossil, a snapshot of the universe in its infancy, and a critical piece of evidence for our cosmological models. Chapter 4: The Invisible Cosmos. When we look at the night sky, we see stars and galaxies, but this visible matter tells only a small part of the story. The universe is largely made of components we cannot see directly. Between galaxies, for instance, space is not entirely empty. It contains rogue stars flung from their homes, faint dwarf galaxies with only a few billion stars, and vast clouds of gas. More significantly, we find evidence for two profound and mysterious entities: dark matter and dark energy. Dark matter is a form of matter that does not emit, absorb, or reflect light, making it completely invisible to our telescopes. We know it exists because of its gravitational pull. The way galaxies spin and the way clusters of galaxies hold together require the presence of far more mass than we can see. This unseen dark matter outweighs normal matter by a factor of about 6. It is the cosmic scaffolding upon which galaxies are built. Dark energy is even more enigmatic. It is the name given to the mysterious force that is causing the expansion of the universe to accelerate. It acts as a kind of anti-gravity, pushing space itself apart. Together, dark matter and dark energy compose about 95% of the total mass energy content of the universe, meaning that the world we see with our eyes and telescopes is just a small fraction of what is actually there. Chapter 5: Gravity and Spacetime. Our understanding of gravity has evolved. Newton described it as a force acting at a distance. Albert Einstein, in his theory of general relativity, reimagined it. He proposed that mass and energy warp the very fabric of the universe, which we can think of as a four-dimensional combination of space and time. In this view, gravity is not a pull, but a consequence of geometry. A massive object like the sun creates a well in space-time. The Earth then follows a curved path, an orbit around this well, much like a marble rolling around a funnel. This theory also predicts that massive accelerating objects, like pairs of orbiting black holes, can create ripples in space-time called gravitational waves. A century after Einstein's prediction, these waves were directly detected, opening a new window for observing the universe. Furthermore, we have learned that the universe is dynamic. It is not static, but expanding. Distant galaxies are all moving away from us, and the farther away they are, the faster they recede. This discovery cemented the idea of a universe with a beginning and a continuing history of evolution. Our place in the universe. The journey through astrophysics reveals a universe that is both awe-inspiring and humbling. We have pieced together a remarkable story, from a hot, dense beginning to a cosmos filled with galaxies, dark matter, and dark energy. Yet, for every question answered, new and deeper mysteries emerge. What is dark matter made of? What is the nature of dark energy? This pursuit of knowledge is not merely an academic exercise. It is a fundamental expression of human curiosity. Understanding the cosmos helps us understand our own origins and our place within this vast reality. We are not merely living in the universe is living within us, as the very atoms of our bodies were created in the cosmic furnaces of stars. By valuing this exploration, by investing in science and nurturing a culture of discovery, we continue this grand adventure of understanding, pushing against the boundaries of the known and expanding the horizon of human knowledge. Our place in the universe. The journey through astrophysics reveals a universe that is both awe-inspiring and humbling. We have pieced together a remarkable story, from a hot, dense beginning to a cosmos filled with galaxies, dark matter, and dark energy. Yet, for every question answered, new and deeper mysteries emerge. What is dark matter made of? What is the nature of dark energy? This pursuit of knowledge is not merely an academic exercise. It is a fundamental expression of human curiosity. Understanding the cosmos helps us understand our own origins and our place within this vast reality. We are not merely living in the universe is living within us, as the very atoms of our bodies were created in the cosmic furnaces of stars. By valuing this exploration, by investing in science and nurturing a culture of discovery, we continue this grand adventure of understanding, pushing against the boundaries of the known and expanding the horizon of human knowledge. That concludes the book summary for this episode. Hopefully, the discussion opened up new insights for you. If you found this helpful, please like, share, and subscribe to the channel. Thank you very much, and I'll see you in the next video.